Okay, so as you can see, I moved the wire back from this negative side of the, so basically it was on the positive side of the diode. Now I moved it back to the negative side of the diode on this negative rail, connected to this, and then I turn this on, and still nothing. Now I move this back over to the ground on this battery from this die. And then I'll turn this on. Nothing again. I don't know why it's not working anymore. Now, as you can see, I take that wire off. Just hold it there. And we turn this on. Nothing. So the Bendini motor won't turn on anymore. I guess I fried the transistor or something on it because it's not turning on or switching or doing anything. The only way I can get it to do anything, as far as I know, is if I touch this wire to this ground side to where this diode on this side prevents the battery from shorting it, but essentially um, we're taking the negative to the positive of this capacitor and shorting that capacitor. And so essentially what's going to happen is there's going to be the current is going to get, it's going to flow in the path of least resistance, right? And most of it's not going to go backwards, but not all of it will, and some of it will go backwards through this circuit. But I think more than anything, what we see is the minimal, the path of least resistance, and it goes back and goes through this coil system. And what we see is a big pulse in current here. See that? Just by tapping it, and it kind of delays when it comes off. Um, so maybe that's the radiant energy tap and a way to convert that energy into more of a current type. Now I'm just trying a continual short essentially right here across that side of the diode with this. It's just sticky on there. And seems like the inverter turns off every once in a while and gets killed by it. Essentially, I just got the negatives connected to each other with the switch off, and I took the output terminals off of everything. So that's just hanging over here. That's not touching anything. And yeah, you can see the Bendini motors off and everything. And so essentially this whole system is decoupled from this system besides this ground. Actually, this ground is off. And then check this out. So I'm just going to touch this whole wire. I got these blocking diodes so current can't go through it, but it'll have a voltage. And then we'll connect this ground. See that impulse? That was kind of odd. And then we'll touch this. See that? So basically, I'm just touching the positive to this negative terminal on this side that's DC full bridge rectifier, and the negative of that. So of course it's avalanching out and into here, creating basically pulses from this down here, creating scalar waves and reactive power. And you're seeing the two E fields come into this coil and be generated into real current from the magnetic component. That's what I believe is going on. So yeah, it's just kind of an interesting demonstration of ether to um, current, from static potential to current to radiative energy back to current again. So I thought I fried my Bendini motor earlier, so I basically had disconnected it just to test it and connected to this battery. And it seems to be working just fine now. As you can see, everything's working on it. So apparently we're affecting some sort of Lenz law action going on within that Bendini motor when you saw that it wasn't running earlier. And then also, what I can show you is that I'll disconnect this here so that battery's not connected at all. And this is connected to a negative, and we got like some diodes like that, and a little capacitor, and then as you can see, there's a blocking diode on the positive side too. And if I take a wire like this, okay, so basically I can arc this across here, and you'll see this massive flow in energy. And I can feel it pulsing down this wire like a big pulse in my arm, like through the insulation. It's kind of wild. And then likewise, if I touch right here on this part in between these diodes, it also works. And you think, okay, well, this is basically, this voltage of this whole dipole. This is positive, and then this is like a lower voltage with this whole dipole. But then, if I touch right here from positive and negative, some of the current can go into this battery, and obviously this is connected to this, so it's kind of like acting in series. So that kind of makes sense. That's going to spark from there to there, like, duh, it's like shorting the battery. But then, like, if you touch on this side of the diode, right here, to this side, you know, this this wire right here is on the negative of this full bridge rectifier, which goes to the negative of this, and this negative is connected to the positive of this supercap bank through this coil, and through the supercap, and through these diodes, which block it. So in theory, no current really should be flowing, um, like essentially positively from that, unless it's sucking in energy, I think. And so maybe this is kind of like the tap right here. It's glued itself on for a second. You can see that's a lot of energy, right? Get this bigger wire to use. So it basically works if I touch like anywhere in here across each other with varying effects. But yeah, as you can see, this neon bulb isn't lighting up right now when I touch it like it was earlier. And then this battery voltage, before I started sparking it, was 2 notches above this 50 mark right there. And then if I were to touch this to this, really hard apparently. So what I got going on is basically trying to block the current as much as possible with a diode from this negative terminal, but using the negative electrostatic potential here to create that all along this section of the line. And then basically the positive side, right, it's connected to the positive rail of the supercap bank over here on the cathode side of another blocking diode, kind of forcing it into the positive terminal of the battery. I noticed this positive connection on this 88 turn coil was coming off of this positive rail, so I was going to redo it. To keep myself safe before I did, I went to go and discharge this, and check that out. See how it blew apart the diode? And it just instantly melted this wire that was on this diode right here. And so if you follow this wire, this goes into the positive side of the battery bank there. So got to make sure to reattach that on the other side of the diode, so that when I short that next time, it's not coming from the battery at all either.